Match latency jumped from 200 ms to 15 seconds. Users saw something went wrong errors. We assumed a DDoS attack, rolled back, no change. The root cause? A single Redis node held the sorted set for Manhattan with 2 million active users, and ZRANGEBYSCORE was scanning the entire set because we forgot to index by geohash prefix. Each query took 800 ms, the queue built up, and the connection pool exhausted. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Design Tinder. Geo-matching is the core of Tinder. When you swipe right, the system finds nearby users who also swiped right on you. It must do this in under 500 ms while handling 1.8 million swipes per second at peak. The architecture uses Geo-Sharded Redis for proximity, Cassandra for profiles, and Kafka for events. Your first instinct is to put all user locations in one Redis sorted set. That works for 100K users. At 10 million, every ZRANGEBYSCORE takes 500 ms. The fix is Geo-Sharding, partition data by geohash cells. Each cell holds a manageable number of users, keeping queries fast. Here's the key design. Each geohash prefix defines a cell. We store user IDs in a sorted set with timestamp as score. When a user swipes, we compute their geohash, add them to the set, then query neighboring cells for potential matches. This keeps each set small. When user A swipes right on B, we need to check if B already swiped right on A. Doing this synchronously kills latency. Instead, we use an event-driven pipeline. Swipe right, right arrow, Kafka event, right arrow, consumer updates Redis sets. If a mutual swipe is detected, another event triggers the match notification. The consumer reads a swipe event, adds to the swiper's set, then checks if the swippy already swiped right. If yes, it publishes a match event. This avoids a synchronous join across databases and keeps latency predictable. Cassandra gives us linear write scalability. We use eventual consistency for profile reads. You can tolerate a slightly outdated bio, and quorum consistency for match writes. You can't afford to lose a match. The trade-off? No joins, so we design schema around query patterns. The schema is simple. Each user is a single row keyed by UUID. We store profile data and last location. Geo-queries go to Redis, not Cassandra. Writes use quorum for durability, reads use one for speed. Without rate limiting, a viral user can overwhelm your Redis cluster. We implement a token bucket per user in Redis, allowing 10 swipes per second. We also use a bounded queue in the swipe service to apply backpressure. If the queue fills up, we reject new swipes with HTTP 429. Here's the pseudocode for the token bucket. Each user has a Redis hash with tokens and last refill time. We calculate new tokens based on elapsed time, then allow or deny the swipe. In production, use a Lua script for atomicity. What if two users swipe right at the exact same millisecond? Both consumers check SISMEMBER and see false, then both write to match events. You get duplicate matches. The fix is a conditional write using a Redis lock. We use SETNX to create a lock keyed by sorted user IDs. Only the consumer that acquires the lock proceeds to check both swipe sets and create the match. The Cassandra insert uses if not exists for idempotency. This eliminates duplicates. This is the same issue we highlighted at the start. Here's exactly why that happened. We had a single Redis node holding the sorted set for Manhattan. At peak, it had 2 million active users. Our query ZRANGEBYSCORE with limit 1000 scanned the entire set because we forgot to index by geohash prefix. Each query took 800 ms, the queue built up, and connection pool exhausted. The fix was to switch to geohash prefixed keys like location Dr. 5 ru instead of a single key. Each geohash cell now holds about 5,000 users. ZRANGEBYSCORE scans only 5,000 entries, not 2 million. Latency dropped back to under 5 ms. Always pre-filter by geohash before running geodistance queries. This was the offending line. By not using geohash prefixes, every query scanned the entire 2 million member set. Always partition your sorted sets by geohash to keep them small. Kafka delivers at least once, so without idempotency, duplicate messages create duplicate matches. Always use insert if not EXISDS in Cassandra. I've seen teams implement rate limiting by writing each swipe to PostgreSQL and counting rows. That creates a write bottleneck and a table lock on the user's row. Use Redis in memory instead. The article mentions using a Lua script as the gold standard for preventing duplicate matches. Here's a concrete implementation that atomically checks both swipe sets and creates the match in Redis, avoiding race conditions entirely. When using Redis for sorted sets and rate limiting, ensure the eviction policy is set to all keys LRU or volatile LRU to avoid losing critical data. The default no eviction will cause writes to fail when memory is full, which can break the matching pipeline entirely. The article mentions splitting a geohash cell when it exceeds a threshold. Here's a monitoring script that checks sorted set cardinality and triggers a split by moving users to subcells, geohash 6, when the count exceeds 10,000. When things go wrong, start by checking Redis CPU and memory. Use Redis CLI to find large sorted sets. Check Kafka consumer lag to see if consumers are falling behind. If a geohash cell is hot, split it. Let's run through some common interview questions. How to handle double swipe race? Use Redis SETNX lock and Cassandra if not exists. When to choose Cassandra over DynamoDB? When profiles exceed 400 KB or hot keys are an issue. What happens when a geohash cell grows large? ZRANGEBYSCORE slows, split into subcells. And a few frequently asked questions. How does Tinder match users? Geo-Sharded Redis for location, Kafka for events, Cassandra for profiles. Why Redis over PostGIS? Redis is faster for high-throughput geoqueries. PostGIS is better for complex queries. How to prevent duplicate matches? Use idempotent insert with if not EXISDS and Redis lock. To recap, Geo-Shard your location data to keep sorted sets small. Use an event-driven pipeline to decouple writes from reads. Cassandra provides linear write scalability, and always rate limit swipes to protect downstream systems. Ready to go deeper? Up next, design Spotify, then design Zoom, then design Google Maps. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.